Thank you so much, Zhou, for being here. Zhou Fang is a software engineer in the Dataproc Metastore team. And today he is presenting gRPC integration and its applications in Hive Metastore. gRPC is a modern open source high performance RPC framework providing advanced features such as authentication and service mesh support and streaming. So in this talk, he will introduce the design of gRPC integration and how it enables new features such as Cloud Run, Endpoint, Fine-Grained IAM, and Metastore Federation. So thank you so much for being here. And this is your space, Joe. Please go ahead.
Thank you for the intro. So in this talk, I will talk about gRPC integration and its applications in Hive Metastore. I'm from Dataproc Metastore team at Google Cloud. So our team is offering a managed Hive Metastore on cloud as a service. First, I would like to give a brief introduction about Hive Metastore. Hive Metastore is the de facto metadata service in the open source data analytics ecosystem. For example, Hive Metastore is widely used by the applications like Hive, Presto, or SpecSQL. What Hive Metastore provides is that it can provide Hive managed table with the metadata such as databases, tables, schemas, and partition statics, with all those information stored in RMDB in the background. It can provide those information, for example, a schema of data on your, for example, HDFS or GCS or S3. So you can have more high-level features on those data, for example, like run a SQL command on those data. And also, Hive Metastore is also integrated deeply with other tools in the ecosystem, for example, like the Turbos and the Ranger for access control. And in recent years, there are also other new open table formats, which also provide managed table features, for example, like Iceberg, Delta Lake, Hoodie. They are also either use Hive Metastore, depends on Hive Metastore, or can be integrated with Hive Metastore. So as you can see here, Hive Metastore is an essential component in this ecosystem. That's why we are keeping invest in improving its experience on it. Before moving on, I would like to also talk about the implementation of Hive Metastore. So Hive Metastore architecture is shown as this picture. So it has two parts. First is a Metastore server. It is stateless, it is standalone, and all the metadata is stored in RDBMS. So Spark and Hive and Presto, all those applications, they can connect to the Metastore server by Thrift, which is the endpoint. From the experience running Hive Metastore as a service, we heard about several pain points about the existing status of Hive Metastore. For example, first, the endpoint support is very limited. Now we use Thrift as the endpoint. So the problem is like, for example, if some users they want to create or get thousands of partitions, you can imagine that the request or the response is huge because there are thousands of partitions. But because Thrift has no streaming access, so everything is in a batch, and the batch can be very large. So this is one issue. So a streaming API would solve this problem. And other issues are like, for example, Spark does not work with those serverless platforms. For example, now we can actually very easily deploy servers on serverless platforms, for example, Cloud Run. But most of the serverless platforms, they only support, for example, HTTP and gRPC. So that's also another limitation from Thrift. And another kind of pain point is that Thrift does not have an integrated solution for authorization and authentication. So the solution currently available like Kerbals and LDAP. But those solutions, they require the customer, they deploy Kerbals KDC or LDAP server by themselves, which is hard to deploy and hard to maintain. So a fully managed authorization or authentication solution would be preferred. And in addition, there's no fine-grained access control. For example, if there are two teams, they are using a same Hive Metastore, and team A can access and modify team B's metadata, because everyone who gets access to the endpoint can do anything inside, because there is no fine-grained access control. So that's another missing piece here. So in this work, we will integrate gRPC into Hive Metastore and solve those problems we mentioned. So the benefit of gRPC, the reasons why we are working on replacing Thrift by it is because many benefits that it brings. Firstly, it's a very high performance RPC framework. Is built upon HTTP and approved by 3. It has built-in authentication support, unlike Thrift, which believes that the customer need to implement those on top of Thrift. gRPC already supports all those authentications. It supports many approaches of authentication, and also is compatible with cloud-native authorization and authentication frameworks, which means that if you use that, it can be easily supported by the cloud themselves. The customers don't need to deploy, for example, Kerbals or LDAP server by themselves. They can just use a token like can be authorized by the cloud vendor. So which make it very easy to use and very safe. And also, gRPC can be easily extended to support more features by the Interceptor API. We will introduce later how the Interceptor API can be used to provide fine-grained IAM control. And it's better supported by Service Mesh, Istio, for example. Service Mesh is widely adopted as the traffic manager for like microservices, and it's also widely used on our end as the service provider. And also, as I mentioned, gRPC is supported by serverless platforms, which means that we can easily deploy Hive Metastore, the server, on those serverless platforms. So it solves the scalability issue of the server itself. Also, gRPC supports both streaming request and streaming response, so which solves the problem of a large batch. With those features brought by gRPC, we are able to implement several new features in Dataproc Metastore. For example, a public endpoint on Cloud Run for Metastore, fine-grained IAM control, and also metadata federation. I will first go through how we implement gRPC integration and then talk about the applications. So our first version of gRPC support works for all existing Thrift Hive Metastores. The reason is that Thrift has been deeply integrated into Hive Metastore, so it would be a long-term work to replacing Thrift inside Hive source code. It will take very long. So to make it work very fast, and the solution we have is that we use gRPC proxy on both server and the client side. On the server side, we will deploy a proxy running together with the server. And imagine that you have a gRPC client, which is a Hive Metastore client. It sends out gRPC request to a Thrift server. So what the proxy do is that it receives the gRPC request sent by the client. It translates the gRPC request to a Thrift request, which is which can be understood by the server. Then the server will process it and return a Thrift response. Then the proxy will translate this Thrift response to a gRPC response and give it to the gRPC client. So from the client's view, the proxy plus the Thrift server becomes a gRPC server now. And yeah, this is the server part of the story. So how the proxy is implemented is that for every Hive Metastore method, we create a proxy method which do the translation. On the client side, we need a similar server, but it receives Thrift request and translates it into gRPC request. So in this way, even though we have a Thrift client, with this proxy, it behaves like a gRPC client. So for this client, we currently have a Hive Metastore client, which is used by Hive and Spark. Presto also has its own Thrift Hive Metastore client, which also can work in this way. Next slide explains how the proxy is implemented. Here are 3 steps. First, we know that we have over 100 Thrift gRPC methods. So what we do first is that we need to create an equivalent gRPC interface. So where we need to define RPC methods, request, response in protobuf. And because there are over 100 Hive Metastore methods, so it's a big work. But luckily that we only need to do it once. So we do it for Hive 2.3.6 and Hive 3.1.2. So this is one-time work. And in future, we can do it for the head branch of the head branch of Hive. And so every time when the Hive Metastore is modified, when someone add a new method to Thrift, the method should be added to the gRPC proto as well. So this is how it can be maintained in the longer term. So after we have the gRPC interface defined, the next step is that about what the proxy should do is that when it receives a Thrift request, it needs to translate it into a gRPC request, similar for responses. So what the proxy do is actually converting a Thrift Java object to a gRPC Java object. So we do it using a mapstruct, which is a runtime mapper of Java object. In most of time, it can automatically do the conversion, but there are some corner cases that it can't handle. For example, in Thrift, when you define a map, you can use a list of objects as a key, which is not possible in gRPC. So for those cases, we need to define customized gRPC structures, proto structures, and we manually handle those corner cases in mapstruct. We need to add more methods to do this conversion. And after 2 is done, then we are capable of converting any Thrift response or request to gRPC. So the last step is that we need to generate the Thrift server or gRPC server for the proxy. And we need to generate a method in this server for every Hive Metastore method. So we use a mustache. This is a library that is a template library that we can automatically generate all those methods based on some rule. Because the implementation of each method is the same, it actually just call the translator we have in step 2 to do the conversion. So with all those 3 steps, the proxy is built. And here we give an example of how the Thrift spec and the gRPC spec looks like. So the idea is that to create equivalent gRPC interface here. After we have in the proxies, we need to deploy them. The current solution is very simple. We just deploy them as a standalone proxies, which means that on the server side, we run the server-side proxy, and on the client side, we run the client proxy. The original Thrift Hive Metastore is unchanged. But in longer term, we plan to integrate those proxies into Hive. We also have a public proposal to the Hive community, and here is the link. And so the idea is that if we will add a new configuration to enable gRPC interface. Once it's enabled, we will create a Hive Metastore gRPC server inside Hive Metastore server. And all the incoming gRPC requests will be processed by this Hive Metastore gRPC server first. and it will translate gRPC request to Thrift requests and forward it to the original Thrift server. So you can see here the Hive Metastore gRPC server is now the proxy. So in this way, it reduces the overhead of deploying these proxies. But still, the issue is that the Thrift still exists here, which means that even though gRPC supports streaming, at the time when it converted to Thrift, you still have the scalability problem if the request or response is large. And also this additional relay of gRPC has additional overhead in latencies. So which are the drawbacks? And in the longer term, we should totally replace Thrift by gRPC to solve those issues. And yeah, this is what we have for the implementation. And so the next I will do a demo to show you how this gRPC works. In this demo, we will use gRPC proxy to connect a Dataproc cluster to Hive Metastore. I already created the resources that we will use in the demo. First, we have a Dataproc cluster called gRPC demo. It has a master node and no worker node because we don't need the worker node for this demo. And I already use SSH to log into this master node and open the two windows here. Also, I have created a Dataproc Metastore service, which runs a Hive Metastore. It exposed a URI, a Thrift endpoint here, and I already connect the Dataproc cluster to this Hive Metastore. So if we take a look at the Hive configuration on this Dataproc cluster, we can see that the Hive Metastore URIs is the same as the IP here, which means that it will use this Hive Metastore. In order to verify it, let's open a new Hive session. At the same time, I opened the backend log of this Hive Metastore. So first, let's take a look at the databases that we have. It only has the default one. So let's create a new database called gRPC demo 1. And we can use this to quickly test that we are using this Hive Metastore by checking whether this database will be seen in the log here. So let me refresh the log. And you can see that the create database request has been printed here, which means that the connection is successful and we are using this Hive Metastore. And we can verify the name gRPC demo 1 here. So this is basically how it works for Thrift connection. Now let's demo how to use a gRPC proxy to do the same thing. So let me close this session. So the first step is to create the server-side gRPC proxy. I use Cloud Run to do this. So Cloud Run is a serverless platform that I can run a Docker image. And so this is my Docker image, which is the proxy. And after deploying it, it will be listening on a URI here for gRPC request. And once it receives any gRPC request, it will convert them to Thrift request and forward it to a Hive Metastore. The Hive Metastore Thrift endpoint is specified here. You can see this is the same Thrift endpoint of the Hive Metastore we just used. So with this Cloud Run service and the Hive Metastore service, we actually get a new gRPC Hive Metastore service because it will be listening on gRPC Hive Metastore request. So this is half of the story. So the next step is to deploy a proxy on the client side. So the client is the Dataproc cluster here, this node. What we will do is that we will run a local proxy using this script. Let's take a look at this script. This is because we will use Docker to run this proxy. So this is Docker image. Similarly is the image of the proxy binary. This proxy will be listening on this Thrift port. Once it receives any Thrift request, it will forward it to this gRPC URI, which is the same as we deploy here. Now let's run this proxy. So the proxy is running now. Now we have a new Thrift endpoint, which is this proxy. And the next step is change our Hive configuration to let Hive use this local proxy, local Thrift proxy, instead of the original remote Thrift endpoint. So it talks to localhost now. Let me restart Hive. During the initialization of this Hive session, it starts to talk to Hive Metastore. As you see, the proxy is getting requests. Okay, so the initialization is done. Let's show the database that we have. We see Jrpc demo 1 here, which means that it's the same Hive Metastore we just used for the last step. So let me do the same thing, create a new database Jrpc demo, call it Jrpc demo 2. And you can see that the proxy received this request. And we can see on the log that it printed. So this log is for the command that we just ran. It's for create database Jrpc demo 2, which means that on Hive, when we create database, it sends out a Thrift request and the proxy received it. And then it sends this request to the gRPC request to this Cloud Run proxy. And this proxy forwarded to the server, which is finally this Hive Metastore. And we can verify on the Hive Metastore, do we receive this request? So you can see here, another database, Jrpc demo 2, create database request is received here. So this is how gRPC proxy works. So as you see, with this local proxy, now this Hive start to use a gRPC client to send out gRPC Hive Metastore request. And together with this proxy on the server side, this Hive Metastore becomes a new Hive Metastore, which exposes a gRPC endpoint, which is this one. So the network connection in between the client and the server is now gRPC instead of Thrift. Okay, that's what I have for the demo. Let me jump back to the slides. Okay, hope this demo already explains how the gRPC proxy works. And if you have questions, we can talk more in the question session. And so the next slide is for the applications enabled by this gRPC proxy. So the current status of our service, Dataproc Metastore, is that there's no enforced access control inside Hive Metastore. So which is also the same for the open source Hive Metastore. Anyone who can access the endpoint can access anything inside the Hive Metastore. Even though there are tools, for example, Ranger, that can give access control, but that works inside Hive, which means that if you bypass Hive and directly use talk to the Hive Metastore endpoint, you don't have access control there. So because of this, because there's no access control, if you can pin the endpoint, in order to protect the metadata, our offering makes the endpoint a private IP endpoint. So which means that in order to use Hive Metastore, you must be in the same VPC network. For example, you can send a request from VMs or GKE clusters, or you can create a, for example, Dataproc cluster using the same GKE, the VPC network to make the connection. So it ensures that the others, the outside your VPC network, they have no access to your Metastore. But this setup brings several like frictions. For example, in order to do private IP, in the implementation, we have to use IP reservation and also VPC peering. But some customers, they are very, for example, they don't have enough IP to reserve, or for example, they have a VPC peering quota and they constantly hit that quota. So those are all the issues. And also another solution is to use private service to connect, but it also requires additional setups. So after we have the gRPC proxy, we can improve it a lot by using a public Cloud Run endpoint. So after we having that, what we do is we deploy the gRPC to Thrift proxy on Cloud Run. And then the whole Metastore is open to the public using a URI generated by Cloud Run. Here is the example is URI.a.run.app. The port is 443, is the port used by gRPC. And because this endpoint is public, so there's no concern about IP issues. And we protect this public endpoint by AAM, which means that there are many permissions that you can define. For example, metastore.databases.create. So anyone who has this permission can create a database inside Metastore. And this permission can be applied to resource hierarchy, include a table, database, Metastores, or even the whole project. And it can be granted to, for example, individual users or a group or a robot service account. So it's very flexible. And after we have this, our customers won't have the issue anymore. For example, that the group A, they have access to group B's Metastore metadata. Even if they use the same Metastore, they can still use the database and the table level permissions to isolate them. So this is what the benefit brings to us. And the reason why we need gRPC to enable it is because that Cloud Run can only listen on gRPC endpoint. And also, we use gRPC interceptors in the proxy to capture the request credential tokens. And then we forward this token to the IAM service for authentication. So this is how fine-grained IAM works. So as you say, both parts requires the gRPC proxy. And also, after we offering this, customers, they can create a gRPC Hive Metastore, which has no Thrift endpoint. To connect to the gRPC endpoint, the customers, they can use, for example, Google's Dataproc clusters. And on those clusters, there is already Thrift gRPC proxy installed, which is invisible to users. So, but in the background, all the Thrift requests are translated into gRPC automatically. And for customers who don't use Dataproc clusters, we will offering the build of the proxy on the client side. So you can easily deploy it by yourself, either the daemon process or a Docker container. So for which the setup overhead is also very low. And that's all I have for today. As a summary, in this talk, I introduced how we integrate gRPC into Hive Metastore to enhance the experience, and how it enables new features such as fine-grained IAM, Cloud Run endpoint, It also supports more features like Metastore federation. But there are still some limitations. The biggest one is that Thrift is still used in Metastore core. So to fundamentally remove this problem and also to reduce the additional latency caused by the proxy, the long-term solution is to completely replace Thrift by gRPC. Yeah, that's all I have for today. Thank you so much.